Hi guys, so today we're going to look at the principle of superposition. Now, it sounds a little bit technical, but we've actually already seen this before. Now, like I said, principle of superposition, we've already applied this to the electric fields and the electric forces topic. But when do we do that? Alright, so you can see here what I've got is, from the electric fields topic, I've got two positively charged particles. We'll call them protons for now, but it doesn't matter. And I've got a point X, and I've labeled that P. So remember what we did is we could just look at one of these charges. So let's look at the furthest one on the left. And we'd say at point P, what is the electric field at that point? So remember, electric fields go from positive to negative. So we'd say that there's an electric field out this way. Okay. Then we go and we ignore the left one that we just did. We look at the one further to the right, or the one in the middle here. And we say, all right, so we've got a positive again. What's it going to do? It's going to cause a force that way as well. And then what we said is, you know, if this point had two forces to the right, we can add them up, and the total force will be the addition of that. So that's just the principle of superposition. So again, on the right here now, if I want to look at the forces of these things, I want to look at the force on the negative particle. So if I ignore the positive at the top, negative and negative, they repel, so there's going to be a force this way. All right, so we'll call that force 1. And now if I ignore the negative, look at the positive, it's going to be an attracting force, negative and a positive, force 2. All right, and then we said the force total equals force 1 plus force 2. Okay, and we added those vectorially. So force 1 was this way. Force 2 was this way. Okay, and we saw that the force total was over there, and this was a right angle triangle. We used some trig, and we found out what it is. So the principle of superposition is something we have definitely seen before, and it also applies to waves in a little bit more of a simple fashion. All right, so there's two types of superposition that happen with waves. The first one is constructive interference. The second one is destructive interference. We'll have a look at that in a minute. But what we've got here is on the left-hand side, we've got two waves meeting each other, just in here. So you can see that the amplitude of these waves is, the maximum amplitude is 1, and it occurs in the same plane. Okay, the minimum amplitude is -1, and that occurs in the same plane. Okay, and then it passes through the medium in the same plane as well, and this happens all the way across. So what this principle of superposition does is it says that when these two waves meet, we add them together. So if this point is 1 and this point is 1, what we actually see, we don't see these two waves. If they're together, we see them adding. So 1 plus 1, it gets a amplitude of 2. Okay, if we come down to the bottom, we've got -1, -1, -1 plus -1 is -2. Okay. And when they cross the plane, that amplitude is 0, this amplitude is 0, 0 plus 0 is 0. So what we see is with constructive interference is these things adding across, and we're getting a larger amplitude, and we're only seeing one wave. All right, so if I try and get a little bit fancy here. Okay, so what I was just explaining there is going to be shown here. So we've got 2 points starting at 0. If you add those together, we get a 0. Now we've got 2 points at 1, and then together we get 1. Halfway up, we've got 0.75, well, 0.5 goes to 1. You can see these are just adding points. And what we're going to do is we're going to trace out a larger wave, and that's what constructive interference does. Constructive means it builds, okay? Obviously, the next one we're looking at is destructive. It's not going to happen that way. It's not going to build upon each other. They're going to cancel out. All right, so what we say is that constructive waves constructively interfere when the path difference is, what does that mean firstly? So the path difference is if you choose a point and you look at an identical wave with the same frequency, what's the difference between those two points? So let's choose the point up the top here. Okay, if we go down the bottom, if we go to a peak on the bottom, it's here. So you see that the difference there is 0. Okay, but let's say we go to this peak and then we go to the next peak. What's the difference between those? All right, you can see that this peak lines up with the next one. So what we say is that the distance between those things is 1 wavelength. So we call that lambda. So the first difference was 0. The second difference was lambda. If I go to this third peak here and start from the first one again, the difference between these is 2 wavelengths, 2 lambda. You can see that. So what we say here is waves will constructively interfere if the path difference is the wavelength. Okay, any multiple of the wavelength. So we say that it's m lambda. So m is the number of wavelengths different. So in this case, it's 2. In this case, it's 1. And our first case, it's, well, I'll just put a 1 there. In our first case, it's 0. All right. So if there's a positive number of wavelengths, we can see constructive interference. And destructive interference follows on really nicely from there. So if we look at our example here, what we've got is we've got a peak here, and if we go down to the wave underneath, so these two things have met each other, and we've got at that same point, we've just come straight down. We've got a trough. Okay, one is up 1, one is down 1. So what's 1 plus minus 1? It's 0. All right, so we can translate that to this graph. It's 0. All right, if we go to the next point where they cross, we've got 0 here, and we've also got 0 there. 0 plus 0 is 0. You're seeing a pattern now. So now, look, we go to minus 1, come down to the bottom one, it's plus 1. Minus 1 plus 1 is 0. So this is called destructive interference. When we add these two things together, they're going to cancel out, and we're going to get no wavelength, basically. We're going to see no wave because the amplitude is 0. All right, again, let's try and get a little bit fancy with that. So you can see here, we start 0, 0, goes to 0, 1, negative 1 goes to 1, and these points all add to a wave that has no amplitude. No amplitude means we can't see it. Okay, so I think that one's pretty self-explanatory after we did the constructive one. So we had an equation for our constructive interference about the difference. It had to be a full wavelength. Now, if you have a look here, what we've got is if we say that we'll go to a peak here, and let's find the next peak on the bottom wavelength. So that's just here. All right. So one wavelength was from the peak to the peak, and we've come about halfway, or exactly halfway, for the peak on the bottom. So what we say is the difference between these two, from here to here, is a half wavelength. Okay. Now, if we start at the first point again, and we go to the second point, we say that distance it's a half wavelength plus. So we've gone a half wavelength, and then we've gone another full wavelength, so plus 1 full wavelength. And that's going to keep going. So we're always going to have that half wavelength plus another wavelength. So the way we can write that is, so we want to have a half wavelength plus, and then any number of whole wavelengths. So we can say a number of full wavelengths. So remove the half and then any whole number after that. But that's a bit messy, and we don't like that. What we realize is there's a lambda, a wavelength in both of these. So we can go, this equals lambda, the wavelength. If we factorize that out, we're left with half. Half times lambda is half lambda plus m. And this is the same thing. So this is what we say the path difference has to be. And this is going to be really, really important in our next little section. So in this section as well, you've been asked to, by the course, to describe constructive and destructive interference in terms of this principle of superposition. Now this is the exact definition. So the sum of the wave produced when two or more waves meet in space is a vector sum of the individual amplitudes. Okay, all that means is when two or more, so we looked at 2 in our examples, waves meet. If we want to work out the wave that it becomes, we just have to add the amplitudes at each point. Okay, if these things are going up and down at the same time, they constructively interfere to get a really large amplitude. If they're going up and down at different times, they destructively interfere to get a single amplitude, and everything happens in the middle as well. So that's the definition. I'm going to leave it there, but thank you.